Okay, so electric power is the last thing that we want to talk about in dealing with electricity. When an appliance is used, electrical energy is converted into other forms of energy. Okay, and the rate or how fast that electrical energy can be converted into other types of energy is called electric power. Now, the appliances that are used to convert this electrical energy into other forms of energy are examples of the resistors that we looked at in when we talked about electric circuits. Okay, electric power can be figured using the following equation. We can do power, which is measured in a unit called watts, equals current, which is measured in amps, times the voltage, which is measured in volts. It can be represented by P equals IV. So power equals current times voltage. Okay, let's look at a couple of example problems. A light bulb is plugged into a 110 volt wall outlet. How much electric power does the light bulb use if the current in the bulb is 0.55 amps? Okay, so the first thing we want to write down is what we know. Okay, we know that the voltage is 110 volts, and we know that the current is 0.55 amps. Okay, we're looking for the power. We need to try to find the power. So we'll use our equation, P equals IV, and we'll just plug in the values, our known values for voltage and current into that equation, which is going to give us power equals 0.55 amps times 110 volts. That's going to leave us with 60 watts. I think it actually equals 60.5 watts, which would be fine if you put that 2, or you could round up to 61 watts. I just rounded down to 60. It's a nice even number that I like to work with. So any of those things are fine, whichever way you want to do that. Okay, the next example we're going to look at says the battery in an iPod provides 6 volts. If the current in the iPod is 0.5 amps, how much power does the iPod use? So the first thing we want to do is to go ahead and write down what we know. We know the voltage is 6 volts. Okay, the next thing we know is that the current is 0.5 amps. Okay, that means that we're looking for power. Okay, so we'll use our equation where power equals current times the voltage. We'll plug in those numbers that we know. Our current is 0.5 times our voltage, which is 6. 0.5 times 6 actually gives us 3. We have to remember that the unit of power is measured in watts, or it can be measured in kilowatts. You can convert that. Okay, so 3 watts. Okay, our next problem says, what is the current in a toaster if the toaster uses 1,100 watts of power when plugged into a 110 volt wall outlet? Again, the first thing we always want to do is write down the given information, what we know. We know that we have 1,100 watts of power. We also know that we have 110 volts, which is our voltage. That means that we are looking for our current. If you look back up in your notes, it has 3 different formulas you can use, or you can always just plug it into your original formula and solve for whatever missing letter you have. So let's do this both ways. First, we'll plug our numbers into our original equation. Okay, so we'll have our power, which is 1,100 watts, equals, looking for our current, we don't know that, times our voltage. In order to get the I on one side by itself, we're going to divide both sides by 110. These will cancel out. 1,100 divided by 110 gives us 10. And remember, we're looking at current, so our unit is amps. Or we could also, since we're looking for current, we could just do I equals our power divided by our voltage and plug our numbers in that way. So our power is 1,100 watts divided by our voltage, 110, and that's also going to give us 10 amps. Okay, our last example says an electric clothes dryer uses 4,400 watts of electric power. If the current in the dryer is 20 amps, what is the voltage? Okay, so we're going to write down what we know. The first piece of given information is how much power we have. So 4,400 watts of power. And we're given a current of 20 amps. Okay, that means that we are looking for the voltage. Okay, so if we use our equation, P equals IV, we plug in our 4,400 for our power. Okay, we have our amps, so we have 20, and we are looking for that V. Okay, so if we divide both sides by 20 to get the V on one side by itself, these two will cancel out. 4,400 divided by 20 gives us 220. Now remember, we're looking at voltage, which is measured in the unit volts. Now, we could also use the formula since we're looking for voltage. We could also do V equals our power divided by our current. If we do that way and we plug in our known values, so 4,400 divided by our current, which is 20 amps, it's going to give us the same answer of 220 volts. Now, the next thing that we want to look at, and the very last thing, is how much this electric energy costs. We looked at power. A lot of times, if you look on especially like light bulbs and things, they'll have a power rating. And from that, you can figure how much electricity costs. Okay, so power is the amount of energy used per second. So the rate that the energy is used and transformed into another type of energy. Okay, so anytime that you use an electrical appliance, which is a resistor, the amount of energy used depends on that power and the time that you used that appliance. Okay, that can be figured. Energy is going to be measured in what's called a kilowatt hour, represented by kWh. And since it's represented in kilowatt hours, we want to go ahead and represent power here in kilowatts instead of watts. Then you just multiply the power times the amount of time in hours that it was used. Your total cost is going to equal your energy in kilowatt hours that we looked at how to figure in the previous calculation, the previous formula, times our unit cost. Now, I know this can be a little bit confusing. We're going to look at an example of this. Okay, Samson washes his hair every day. He spends half an hour drying his long hair with an electric hair dryer with a power rating of 1.5 kilowatts. If the unit cost of electricity is 9 cents, how much does Samson spend drying his hair each day? And how much does he spend each week? Okay, so the first thing we always want to do is write down what we know. Write down our given information. Okay, we know that our power, okay, it tells us right here, our power It's going to be 1.5 kilowatts. It also tells us our time. It says he spends half an hour. Okay, so 0.5 hours. And then it tells us our unit cost is 9 cents. Okay, so we're trying to find the total cost per day, and then we'll find the total cost per week. We're going to start by finding the amount of energy that was used. So we'll use the formula energy equals power times the amount of time used. Okay, so we plug in our known values. Okay, we have our power and we have the time. We'll plug those into that formula to figure out how much total energy was used. 1.5 times 1/2 equals 0.75. Since we're multiplying our kilowatts in an hour, that gives us our energy unit of kilowatt hours. Okay, next we're going to find the total cost per day. Notice that I went ahead since we figured energy and I've put that up here with our other known information. Okay, so our total cost formula is going to be our energy in kilowatt hours times our unit cost. We've already figured energy and our unit cost was given, so we can simply plug those numbers into the formula, giving us 0.75 kilowatt hours times 9 cents. That gives us 7 cents per day that it costs Samson to dry his hair. Now, we can't forget, we've also got to figure out how much it costs per week. So we know that if he spends 7 cents per day, and there's 7 days in a week, we can simply multiply the 7 cents times 7 days for a total cost of 49 cents per week.